presented by the engineers here who are currently working on the design and the development of these features. After today, we still have a few more days for clarifications before moving forward with the release, with defining the block activation heights and so on, unless, of course, there is a pushback from the community. And this is pretty much how the process typically works. As a very quick intro to read, read includes 4 RSK IPs that are aimed at improving Rootstock in a couple of areas. First of all, decentralization of the network, specifically by improving the trust assumptions of the current bridge, the PowPeg. That's the focus of RSK IP 305, which will be presented by Marcos in a few minutes. We are also proposing a new bridge design called Union, which will be introduced by Sergio later on. About Union, yeah, it's something that we've been talking about for some time now, but not in a space like this one. And this new design or type of bridge requires 2 additional RSK IPs, 502 and 516, to be incorporated into the protocol. So we will go through them later. And on the other hand, we are looking to enhance scalability, essentially increasing the number of transactions the network can handle in a given time. And that's the focus of RSK IP 144, which will be presented by Fred. We are proposing to bring one of these improvements to both Testnet and mainnet, as it's usually the case. That's RSK IP 305. And for the other 3, the proposal is to launch them on Testnet only, at least initially. The idea is basically to have these larger and, let's say, more disruptive changes in a safer environment, gather feedback from users, partners that are currently working on Rootstock Testnet, and then decide on the best time to bring them to mainnet. After some conversations we've been having with the different teams working on READ, and considering that some of these features will need a little bit more time, we are also looking at 2-phase rollout strategy. This basically means that we are starting with RSK IP 305, hopefully very soon, followed by the Testnet-only features shortly after. So we are thinking of having 2 different releases for READ. That said, we don't have specific days yet. Of course, we will wait to see the community's feedback before locking down the timeline. But some high-level overview, we are considering end of August for the first release and probably September or early October for the Testnet-only features. But that's, of course, something still to be defined and will be communicated very soon. So again, everyone's welcome to share questions during this call. If you're not watching live, the best place to leave the comments is on the Rootstock Research Forum. That's you can see the link on the slide, and I'm sure Bachi will also share it in the chat. And yeah, that's the intro. Back to you, Bachi.
Awesome. Thank you, Adrian. So now let's go dive deep into each RSK IP. Next, we have Marcos, if I'm not wrong. Hi, Marcos.
Hello. Hello, everybody. This RSKP propose an efficiency improvement in the payout process in the PowPeg. It has 2 improvements. One is making payout fees 40 to 60% cheaper. Those are the fees paid in the Bitcoin transactions when a user does a payout. And the second improvement is increasing the decentralization of the PowPeg. It will be now technically possible to have up to 20 members. The current maximum is only 9. So this, technically speaking, the way this is done is by making the PowPeg script P2SH wrapped, also known as Segwit compatible. So this allows for larger scripts and cheaper transaction fees, since signatures are moved into the witness of the transaction. So that results in cheaper fees, even when having more signers. So as far as we have analyzed and the tests we have executed, even having 20 signers with the new format is still cheaper than having 9 members in the current format. So yeah, that's really a very positive thing. And if you can move to the next slide, please. So yeah, I want to talk now about future improvement proposals, some things that we will be working on or we will be proposing to the community. And there is an idea to change the script of the PowPeg so we can support up to 60 members. That would give even more decentralization. Improve the UTXO selection when creating the payout transactions. That will make also cheaper payouts, since it will consume less inputs each transaction. And finally, the idea of when a PowPeg composition change is voted, that the migration should be done to multiple UTXOs, multiple outputs. So when the new PowPeg activates, it already has multiple UTXOs available to process multiple payouts at the same times. That would prevent some delays that sometimes happen after a PowPeg change, where there's not many UTXOs available, so some payouts get delayed in a queue. So yeah, all of this will be presented in the research forum as usual, so for the community to discuss.
Awesome. Thank you, Marcos. Yes, if you're watching on YouTube or Twitter, we just dropped the link for the research forum. Make sure to leave your comments, or like let us know in the comments as well if you have any questions for the team right here. They're here to answer all of your questions or your thoughts, all your comments. Moving on, we have Fred. Fred is going to share a bit more about RSKIP 144 parallel transaction. Tell us more about that.
Hello, everyone. So yeah, together with some big change that we are also adding this new one, parallel transaction execution for the unit try. It's a long-awaited feature. The biggest gain that this feature will bring to us is like the ability to actually run parallel transactions. Not because nowadays all the transactions are being executed sequentially, and then this feature will bring the possibility to expand this, and of course, like bringing more flexibility and then being able to process more transactions in the same amount of time, like, and not compromising the block time generation. And of course, like this will generate, we have to align with together with miners. We propose some algorithm that the miners will build this transactions list in a way that a secure way, basically meaning that the transactions that are being processed in parallel cannot affect the state of each other. So basically, we build sublists of transactions, and this sublist like contains transactions that doesn't affect the state in parallel. And then at the end, we're gonna build like a list of the sequential transactions that is necessary to be running. And this will bring, of course, some change in block validation gas limits as well, and some change in the block extension header. I think that in the next slide, please, Bachi, we're gonna have like a better visualization of how this will work. Like basically the possibility of like have multiple threads. Like let's say we'll have one list, the thread one with the list of transactions, and then you have the thread two with a sublist of the transactions, and the thread three with another sublist. Basically, the thread one, two, and three will be running in parallel, and then at some point we're going to have like a synchronization point where the rest of the sequential transactions will be executed, and now each of these sublists will contain like a subset of gas limit to use in the transactions. And this is basically the biggest change that we have for this. There's a lot of validations, and we need to assure that this is working properly and not affecting the security of the blockchain. But we've been working a lot on this, and we're gonna release this soon to also improve our network. That's basically the summary.
I may add here that during the validation process, if there is a conflict between the transactions in thread 1, 2, and 3, then the block becomes invalid. So there is an incentive for the miners to create schedules of transactions that are actually correct and does not lead to any uh, incoherence with the state of the after processing. So the schedule that is created by the miners make sure that everyone agrees to the same end state of their processing.
Yeah, thank you, Sergio, for the
I,
addition.
I have a question about this, if I may.
Sure.
Does this affect in any way the cost of transactions or the speed of block creation?
It's a good question. Well, since since new computers have many cores, and they will have more cores over time. So that means that processing for us is getting cheaper. So we will be able to reduce the cost of transactions. Obviously, this is a market thing, but essentially, if it costs less to execute those transactions because we can do them in parallel and do not affect the processing of new blocks, then that should impact and make increase the size of the block and make the transactions cheaper. Regarding the production of blocks, we are using an optimistic system for creating the transaction schedules, which is pretty good at this point. Obviously, you can improve that, but when you try to improve the scheduling, then what you get is more time to create blocks. And that goes against the interests of the miner, which wants to propagate the block as soon as possible. So there is a sweet spot where you invest certain amount of energy or resources trying to get the best schedule, generally when the block is full. But if the block is not full, you just do optimistically and you get a good enough block to get the maximum fees for the miner.
Okay,
Yeah,
sounds good.
just a quick comment in line with what's introduced at the beginning. The idea of these changes to sit on testnet first. So it will be activated on testnet. No dates defined yet, as I said before. But the idea is to get feedback and see it's in action on a production environment like testnet, although of course there's no real money there, and then decide the best time to move it to mainnet.
I want to add
Awesome.
that, sorry,
Go ahead.
Abachi, that
No, go ahead.
very few blockchains have parallel transaction processing, EVM compatible parallel transaction processing. I think there's only one, and I'm not sure if it's in mainnet already. So this is really, from the point of view of innovation, is really something completely new in the ecosystem.
Good. That's a good segue because now we have you, Sergio, presented a bit more about Union Bridge.
Thank you. Thank
Yeah.
you, Bachi. So formally, hello to everyone. Thanks for being in this important meeting. So I've been talking about the Union Bridge for a long time, like more than a year, several presentations, but I think this is the first time that I propose this to the community, and I get your feedback on this. I see everyone frozen. Maybe it's me that my internet connection is not good enough, but I will just go on. Okay,
We can
Yeah,
hear
yeah.
you. We
Go
can hear
ahead.
you.
Yeah. Go on.
yeah.
Don't worry about that. The stream will like
Okay,
accommodate itself. But yeah, go ahead.
excellent. Next one, please. Okay, so before we start, just a few words of what is a bridge and why it's important. Next one, please. Okay, so the history of bridges started with single custodian bridge, and then bridge have evolved with the multi-signature federated bridges. The PowPeg, which is really one of the strongest and more robust uh, bridges that have been created because it's HSM based, and each HSM base is consensus driven, and so there are many parties with a multi-sig, so it's also federated, so it's super strong. But we want to make it even stronger and even more decentralized, because we think that Bitcoiners really want layers 2 that are fully decentralized. So we are going to attack this problem. We are going to solve this problem with creating an optimistic bridge. Okay, and this is something that has not been done before for Bitcoin. So we are creating our own innovations and our own technology to make this happen. Next one, please. So first, a few words about the PowPeg. It's a Rootstock native bridge. It has been working since 2018 without any security incident at all. It's very robust, as I mentioned. It allows you to send and receive RBTC. It has an SPV node inside it, like that is used to detect what is happening on Bitcoin, but also gives Oracle services um, for Rootstock transactions. But obviously, the community wants something more decentralized. Okay, next. So let's see, the good thing about the PowPeg is like the keys are secure in HSMs. We have many participants, like 9 pegnatories, and that's a lot of security, distributed security. And then we have the 1-year time lock emergency multisig. If anything could happen to it, then the funds will be locked for a year. We have this HSM that runs the Rootstock-like client. We have this feature that is called public firmware attestations, where anyone in the community can see what is happening in each one of the devices. And also, I don't know if this is public or not, I don't remember, but there is an SGG or Intel-based version of the bridge already created by Rootstock Labs. But there is a bad thing of this. It's not fully permissionless, right? Because since we have a majority assumption of the set of pegnatories, it means that we cannot let anyone participate, because they can obviously dilute the security, right, with a cyber attack. So it's not as trust minimized as we'd like it to be. And also there is some root of trust in Ledger, the manufacturer of the HSMs, and Intel, the creator of the SGX enabled processors, because they are the ones that are creating these firmware attestations, signing with the manufacturer key. So these are the critics. So we wanted to make something that it's even more secure, but more decentralized, essentially. Next one, please. So that's why we put a lot of effort and a lot of research to create the Union Bridge, which is an optimistic BitVMX-based bridge. Next. So the Union Bridge was designed by Rootstock Labs and Firegate Labs, these two companies together started this endeavor, and they together created the BitVMX protocol, which is one protocol that allows you to do optimistic verification of smart contracts on Bitcoin. And this is the flavor created by Rootstock Labs, and it's much more efficient than BitBN2 that was created by the BitBN Alliance. So we have very cheaper disputes, and so it's a protocol we are very proud of, and it was also created by Rootstock Labs. And it has 3 core protocols: the setup, which happens obviously at the beginning, then we have the peg in, peg out, and then we have this obviously we have the peg out optimistic protocol, where we basically, when there is a burn request on Rootstock Lab or Rootstock blockchain, sorry, a transaction needs to be RBTC need to be transferred back to Bitcoin. Then we have to create a zero knowledge proof that this event happened on Rootstock, and then this is verified optimistically on Bitcoin. And then there are some auxiliary protocols like committee fund migration. Participant now can join and leave the committee. That's what makes this bridge really permissionless, right? If you want to participate in the security of the bridge, you are one of the creators of a major protocol on Rootstock Labs. You are a user and you have moved a lot of funds into Rootstock. You want to make sure that you are the one controlling and watching for the security of the bridge. You can do that and become a bridge liquidity provider or watchtower. These are the 2 roles that you can participate in. Next, please. So what we managed to do with this new technology is we started from the honest majority trust assumption, which is what the PowPeg relies on, and we get to, next please, to the 1 of n trust assumption. This means that we only need one participant, to be honest, from a set of any number of participants, which are this committee. And if one of them is honest, we are able to challenge any attempt to peg out with an invalid proof, right? So this allows us to grow this committee size as long as there is at least one honest participant. And we know that there will be many initial participants in this protocol, or possibly the PowPeg members, the current PowPeg member would switch and become also watchtowers or liquidity providers of the new bridge. There are essentially these roles in the bridge. We have obviously the user that peg in and peg out, the Rootstock blockchain. We have two new roles. One is the operator, which basically can forward funds, can front funds to user and be reimbursed by the protocol. And we also have a watchtower role. If you want to participate in the security of the protocol, but you don't want to be a liquidity provider for any reason, regulatory, or you don't have the capital, then you can still secure the bridge. Okay, and obviously we have the Bitcoin blockchain. Next. So let's do a side-by-side comparison, a very quick one. So why for us it's so important to switch to this new bridge? We get a lot more decentralization. The fact that it's permissionless is completely new to Bitcoiners, that you can create a permissionless bridge. Currently, the current PowPeg allow us to do 20 with the new RSKIP, and obviously almost 60 with some improvements that we have in the pipeline. But with the Union Bridge, we can get to 100 or more. Okay, so we can even make it more decentralized, permissionless, and bigger in size. And we have this new security assumption where we only need one of the N to be honest. And we can, something completely new is that we can reduce the time for pegouts depending on the pegout amount. So if you are going to peg out a small amount of Bitcoin, then maybe it takes 30 minutes to peg out. And if you're going to peg out several $1 million in Bitcoin, then it may take 20 hours to peg out. And this is great because in the current PowPeg design, you always have to wait 2 days for any kind of peg out. So that's why most users use other methods such as swaps, because they don't want to wait 2 days. But in the new system, you will be able to wait depending on the amount you want to peg out. And there are some, I would say, downsides of the new bridge. We don't know the private key, the security of the private key of each of the pegnatories, because we don't give them HSMs. They can connect and enter the protocol with whatever hardware they want. So we don't have that benefit. And the protocol is more sensitive to liveness. So participants in the protocol must be live at all times to allow peg-ins and peg-outs. And we will penalize any participant that is not live at the moment when it's requested. For simplicity, we are starting with fixed denominations. So let's say we have, you can pay in and peg out with 0.1, 0.01, 1, 10, etc. BTCs. And if you want to peg out with some fraction, you can split it in smaller units and then peg out. So you will be able to, but essentially, initially, we get fixed denomination peg out. And each one of the participants of this committee must post a security bond, a security deposit, to make sure that if the participant misbehaves, either by trying to misappropriate funds from the bridge or by not being live when it's requested, it's penalized. Okay, so these are the things that you could consider downsides, but the benefits outweigh the downsides far, right? Next one. So we have a roadmap that obviously we propose to the community, and we want to keep discussing this with the community. In July, we will do the first launch of this bridge on the AlphaNet, which is an internal testnet that we use in Rootstock Labs. So this is a private launch. If you want to participate somehow, let us know, and we can let you review it. But then there will be a release on Testnet on November. We think that we will be able to reach that point and show everything working to the community. With obviously, we are open sourcing the code as we go, month by month. But by that time, the full code obviously will be open source. And our plan is to get to mainnet on January. Obviously, if the community has any different ideas of the rollout plan, we are open to review it, but this is our current plan. And during next year, we'll be doing continuous improvements, because first we want to really test this on testnet, which is the most important stage for us. And we have a lot of new ideas for even improving the security once it's deployed in mainnet. So next one, please. So for us, the priority is security. There's thousands of Bitcoins locked in the PowPeg right now. They have been secure for all this time, and we don't want to change that at all. We don't want to introduce any risk. So we are having a very strict deployment plan where we put the security first. Both breaches will coexist during next year, that's for sure, if we continue with this plan, so that we can launch the union breach with a cap on the amount of funds it can handle. In that way, if there is any problem, we can make users whole or bring the Bitcoins back to the system without affecting anyone's money, right? Obviously, we don't want that to happen, but we want to make sure that we do the required steps to be fully secure, right? So we will undergo, the system will undergo several security audits, and we put this cap. And this cap, this is very important, this cap on the amount of Bitcoins that can be handled by the union breach is enforced by the native legacy breach. So it's native consensus code. It's not Solidity code. It's not something that we will introduce in Solidity. You can think of it a kind of firewall that protects the funds in the PowPeg breach against any potential malfunction of the union breach. Okay, and then Marcos is going to talk more about this how this is going to be changed in the legacy breach to support this firewall. And we plan to have a security council during this brief period of time where we have the cap, where we could adjust certain security parameters. Eventually, if there is a security problem, upgrade the contracts, increase the cap, and pause withdrawals for a fixed amount of time. But the important thing here, and next slide, please. The important thing is that once the cap is increased, some of these authorizations will be revoked. So the soon we increase the cap, the Security Council will have no more control of any of these functions. So these two things will be related. And so to make sure that once the system is ready, the system is fully decentralized, okay? And to give you an idea, we use this cap strategy when we launched the PowPeg for the first time. So we know that it works. We know that it helped a lot in the beginning. So we are going to reuse the same strategy again. And for a comparison with other BitVM protocols, what we know from talking with the other teams and from articles that have been published is everyone is going to have their own sort of security council. For instance, Citria will launch with an emergency multisig, right? So it's not new that these new systems launch with some sort of fallback or security council to prevent any damage, okay, to the system. And we think that the cap is more decentralized than the emergency multisig. So that's why we are going with the cap. And next one. Okay, so what's in the roadmap in the future? So while we were working on the union breach, we had a lot of new ideas from Rootstock Labs, from Fairgate Labs, and these are the ones that have been published or are soon to be published. So BitVMX for garbled circuits. This is a boost on the efficiency of the breach, and there is a paper coming soon, and we will integrate this to union breach. Then there is the transfer of ownership protocol. This is a protocol we have already published, and this is a protocol created by Fairgate Labs, and that allows you to do the same breaching, but without the need for fronting the funds, which is obviously a pain point for the operators. Then the last week, we published the Flex fraud proofs with lightweight escrows for exits. This is a new design of a breach that goes hand in hand with the BitVMX forgable circuit that allows you to post the security bonds on demand instead of having them locked during the whole time, which obviously it represents a financial cost. We can use the security bonds only when there is a dispute, making the bridge more efficient. And then there is a new protocol called Battle that I'm going to talk more about in the upcoming month because the paper it's going to publish. It's going to be published. And well, this will make the Union Bridge cheaper, faster, more decentralized, more collateral efficient, and more secure. And I hope we can deploy all these changes during 2026. And I think that's all I had to say about the Union Bridge. Is it?
Yes. Yes,
Yeah.
it's everything. We will have more of you in a few minutes. But now, thank you, Sergio, for this deep
So,
dive.
Thanks.
Go
sorry,
ahead,
actually,
Marco.
I have a
No,
question
no.
about the union. You mentioned, Sergio, that union and PowPeg will both coexist during 2026 at least. So, from a user's perspective, will a user need to choose which bridge to use, or will there be like a default option? And also, if users can peg in through one, peg out through the other, how
Yeah.
will that work?
Mostly, yes, the user will have a choice. And the Rootstock Lab has already a web page where you can choose for different methods to peg in and peg out, either the flyover system or the native or swaps. So I think this will be integrated as a new method with its own cost. So user will be free to decide which bridging method to use, right? And because we think that we don't think, I mean, we've proven that the cost of the new bridge will be lower to the user, to the end user. We know that most users will prefer to use the union bridge, right? But if there is, since there is a cap, if that cap is reached, obviously the users will have to fall back to the PowPeg bridge or any of the other swap methods, right? But yeah, this is how it must be to protect the funds.
And you can enter through one and exit through the other.
Yes,
Independently.
yes. As long as there is the cap is not reached, you can do that, and it's perfectly fine. And yeah,
That's great.
And one comment, while both bridges exist, and although we think that Union is kind of a better design because of all the things that Sergio said, the PowPeg will still be live for some time. So that's why we are proposing to keep improving it. That's like related to our RSKIP 305 that Marcos presented at the beginning, with this idea of reducing the costs of paying out and increasing the size of the federation, the number of members. So yeah, the idea is to keep it improving until we get to a point where like Union is the only bridge working.
yeah. Also, there is an idea of mine that it was rejected initially by the community, but I can bring it again. Is that combining the two bridges could give even more security, like having the HSMs reused for the new bridge, like some parties using the HSMs in combination with the Union bridge could boost the security. So maybe I make a formal proposal to the community later
You
on.
have to try again.
I have to try again with a more formal proposal. Maybe I get better feedback.
Thank you guys. I think that's this is a lot coming. So now we have Marcus again. He's going to talk about the union, the union bridge integration. So let me just share this. Go ahead, Marcos.
Okay. So connecting to what Sergio just presented, since there will be two bridges providing ways to go in and out from Rootstock, this RSKP proposes a way of how the two of them can integrate, especially on the Rootstock side. So there is basically a single source of RBTC that is the bridge contract that from the Genesis block, it has 21 million RBTC. That's equivalent to the max amount of Bitcoin in existence, since RBTC and BTC are always pegged 1-to-1. So now there's this new actor, the Union Bridge, that will also bring users into Rootstock. So whenever a user makes use of Union to peg in, for example, the Union contract needs to request the native bridge for RBTC in order to fulfill the user's request for RBTC. And same thing when there is a peg out. When there is a peg out, BTCs are unlocked from the bridge. The Union bridge needs a mechanism to return those funds to the native bridge. So the native PowPeg bridge will still act as the holder of the RBTCs that are transferred to users as they do peg-ins, and they're transferred back to the bridge as the users do peg-outs. So this RSKP proposes a few new methods in the bridge. One to request RBTC, another one to return RBTC. Both of those methods can only be called from the Union Bridge contract address. There is also, as Sergio was mentioning, a cap in the amount of RBTC that can be transferred from the native to the Union Bridge. So that cap will be closely monitored, see if it's worth it increasing it, if it's reached, or that will be a community decision, but that's a security consideration. There will also be a pause mechanism. So in case of any strange behavior or anything goes wrong, the integration between Union and the native bridge can be paused independently for peg-ins or peg-outs. Any of them can be stopped at any time. And well, yeah, the plan is to release this new RSKP only active in testnet as the development of the Union Bridge advances. And well, as Sergio was saying, the idea is to have a version in testnet in the upcoming months. Yeah, it will only be active in mainnet once the project has been properly tested in testnet first, and when it's ready to go to mainnet, this new method should be enabled in mainnet.
Awesome. Yeah, Sergio, go ahead if you had any comments or anything.
Yeah, I want to add that this pause mechanism only affects the Union Bridge, so the PowPeg will not be paused. Like this is very important. The funds, the user will always be able to retrieve the funds and withdraw the funds into Bitcoin, right?
True. Yeah, the PowPeg remains decentralized. The users can make use of it without the need of the pegnatories to peg in. They need the pegnatories to peg out because they need a signature, but that keeps working as usual.
Excellent.
Awesome.
Just
and I think,
quick comment, sorry, Bachi,
Yeah.
to emphasize what Marcos was saying. This is only for testnet, and seeing this activated on mainnet will require another network upgrade that needs to go through the process as any other network upgrade. So Reed is proposing to activate this only on testnet, and we will, if we want to see a union happening on mainnet, we will need to see this RSKP and next one, and probably other ones being included in future network upgrades, hopefully before the end of the year. But this is proposing to activate this only on test.
Great. Well, we have the last one with Sergio. I'm not gonna try to say that the title because it's complicated for me. But Sergio, all yours.
Okay, so this is one of the features that can help not only Union Bridge, but many protocols that that are connected to Bitcoin, and we want to see more protocols that really integrate Rootstock with Bitcoin transactions, because we have the SPB Oracle, and we see a lot of synergies with combining Rootstock with Bitcoin. So in Ethereum has big integer opcodes. So you can add big numbers. You can even do a modular exponentiation of big numbers. And but it's very inefficient to implement cryptographic operations over the Bitcoin curve, the Bitcoin elliptic curve, if you have to do it from zero, from scratch. And it's not only inefficient, but it's also very error prone. And you should not implement your own cryptographic libraries. You should use existent, proven, secure cryptographic libraries. And this was the strategy that Ethereum took when Ethereum implemented the EIP 186, which was the addition and multiplication operation for the AltVN 128 curve. And this was important to verify snarks on Ethereum and to create this rollup, the first rollup on Ethereum. So the idea was, okay, because needs to be very efficient, and because we want to reduce proven components, we will create precompiled contracts that provide this point addition and scalar multiplication on Ethereum. And so we wanted to bring the same functionality, but for the elliptic curve that is used by Bitcoin transactions. And this will allow to use several protocols, such as the music2 signature aggregation capability on Rootstock. So we will be able from Rootstock to aggregate many Bitcoin signatures into a single Bitcoin signature and make these protocols a lot more efficient. And Union is one of the protocols that will make use of this feature. It can work without this feature, but it makes it just a lot more efficient. So Union Bridge has a mechanism that we call it super optimistic pegout, where basically if all the pegnatories agree that a certain event, a certain pegout operation is correct, then all of them sign a transaction with their own shares of private keys, and then these all signatures are combined into a single signature, making the pegout the smallest possible transaction. So it's very, very efficient pegout system, because even if you have 100 pegnatories, you get just a single signature. And to aggregate all these signatures, you want to have an efficient method to do that. And for that, you need this addition and multiplication operations on the Bitcoin elliptic curve. And that is this RSK about. It's very technical, very focused. It doesn't affect any other part of the Rootstock system. It's just a precompile that any contract can call and make use of it. Yeah, I think that's okay. So the specifics are, there are two new addresses that will hold these new methods. The encoding is similar to Ethereum EIP 196 to make the libraries very easy to work with, because most of them are already written. And the costs were adapted a little, like the addition of point cost is adapted from EIP 1108, and it's 150 gas units. And the scalar multiplication was taken from elliptic EC recover, the precompiled to recover the public key and the address from a signature. And EC recover actually performs two scalar multiplications, and the cost of EC recover is 3,000 gas units. And so even we could make a multiplication half of EC recover cost. We take 3,000 to be more conservative. We will set the gas cost to 3,000 gas units. Okay, so that's how we arrive at the gas cost. And I think that's all for this SKP.
Yes, exactly. We're finished reviewing all the RSKPs. We have one question that I think when it's Marcos was presenting. And I don't know, Adrian, if you have anything before this, or I can just ask this question.
Yeah. Go ahead.
Okay. It was how do you choose signers? They were asking about signers. Maybe if it's Marcos or maybe Fred. I can't remember who was talking at the time, but if any of you have answers for that.
I suppose we are talking about the signers of the Union Bridge.
Yeah.
I guess.
Yeah.
Okay, so obviously, some of the ecosystem participants, we already know that they will want to be these signers, these pegnatories, these participants on the union bridge. But essentially, the system is permissionless, which means that if you put the security bond, and obviously, if the maximum numbers of committee members have not been reached, I mean, there is still slots for you to participate, then anyone will be able to participate. So you want to be a signer, you go ahead and just register with the union bridge.
Awesome. That was the only question for now, guys. But I'm sure that there will be more in the research forum. Do we want to go ahead and do a final recap for everyone?
Yeah, absolutely.
Awesome.
So yeah, so the Read network upgrade, we have presented the 4 RSKPs that we are proposing to include as part of this network upgrade. You have the link there to the what we usually call the meta RSKIP that includes links to each individual RSKP. Of course, during this call, it was a very high level overview, but if you go to the RSKIP, you will get more details of each of these ones. So that's kind of the entry point for Read in GitHub. As I mentioned at the beginning, we are thinking of this 2-phase rollout strategy with days still TBD, still to be defined, but we are pretty confident that we can very soon release the first part of Read with RSKIP 305, which is the one that Marcos presented that will bring improvements to the PowPeg in terms of cost and the number of seats available to join the PowPeg. And at a later stage, probably September or October, bring these like bigger changes to testnet as a part of this second release for Read. Also, as mentioned at the beginning, this is open for comments until August 22nd. That's around 2 weeks from now. Of course, if there are like a big pushback from community, then this will be analyzed and presented again. If we don't see anything being mentioned or anything relevant, the idea is to move forward with the release again, hopefully by the end of August. But that's a link where you can access and leave your comments about Read. And yeah, I think that's basically it.
Awesome. Thanks everyone. Thanks for joining. As Adrian said, we dropped the links on our YouTube and our Twitter, and also look out for Discord. Yeah, if you have any comments until August 22nd, it's open. If not, feel free to reach out any of these guys on Twitter and social. Thanks a lot for your time, everyone. Always open to any comments. Check our Discord, check our Twitter. We're here to connect with you and learn more about you. Thanks. Have a great one.
Thanks, everyone.
Thank
Thanks,
you.
Bachi.
Bye-bye.
Thank you. Bye.
Bye.